going to start linked list. I have just written this linked list word in the paint. Just please anybody confirm me that yes, the screen is visible. Just confirm me. Yes, okay, fine. I got the confirmation. I no need more. See, what we expect or what we want to do. Suppose there is a huge amount of data to be stored or to be managed. Say a student list. See, if I consider a student list, how I can identify a student? Name, roll number, section, enrollment number, so and so. And suppose I want to add the marks also, the GPA, I can add that also. Maybe your different column with enroll, name, section, role, and the marks. Okay. So these are the things that we require. Now, it's for, say, one entire batch or anything else. Now, entire batch, maybe in case of UEM, that may be 700, 800 and all. So what can I do? Can I take an array for enrollment number, one name, one section, one role, and for each array the capacity is 700, 800 and so on. But obviously, that's not at all a feasible thing. So what we have learned that if I need to deal with various type of data type, then obviously struct something we can store various type of data. Not necessarily it has to store various type of data. It can store, it has the option to store various kind of data. It's not like that every time it have to store the various kinds of data. It can support non-homogeneous data. Can support non-homogeneous data. Okay. So as up to this we know that structure can store, and they also store in contiguous manner. Fine. They store their element now. But when we are talking about linked list, what is that? Now node linked list is a, you may say it's a collection of node. One node is connected at least to the next node, means if not more. I'm just talking about a single link at present. So the at least one link may be there. Nodes are present in different locations. So whenever we are talking about linked list, we should remember, with those who have studied multiple times and understood all these previously, it's okay. But those who during data structure, or when they are in the first year, when things were discussed, not that much attentive and didn't have listened to the all this instruction. So you need to remember all these things. A collect linked list is nothing but node. Every node is a structure type. One node is connected at least to the next node, and nodes are present in different locations. So I was telling at the beginning, the structure is storing continuous data. That means what? If I write here struct character section int role, sorry, struct student I should write here. And then if I take struct student B1, and then I take one input for B1 section, B1 role, then in the memory, this structure will get stored as, suppose it's section A and roll 25. So this is 1 byte, and if it integer is 4, then as a whole, this is 5 byte data, and this is a complete block. But when we are talking about linked list, then the nodes, see, information within the nodes are in contiguous manner, but individually nodes may be in any manner. They, if the memory space is available, then they may be in contiguous, but no requirement of that. And the way you will learn to code this, it's not bother. The node may be anywhere. So the next node of this may be this, next node of this may be this, the next node for this node may be this, and next node for this node may be this. Anything can happen. So this way things can be in a scattered manner. Okay. So linked list is a collection of nodes stored in the memory, maybe in scattered manner. If by chance the space is available in a contiguous manner, they may be stored in contiguous manner. But we don't bother that whether they are stored in continuous manner or not, because we don't bother. We just bother that whether the node is getting space in the memory or not. If it is getting space in the memory, it's well and good. And which is important, this link. Because if I lost this link, any of the link, I will lose the track. If I consider this is as my starting point, and if I lost the address of the starting point, then again I will lose the entire list. Okay. So this is the way. This is, you may consider the engine, the starting node, and rest of them are bodies. Now I will share the PPT that I had made earlier when I had teased those in the data structure class. We will discuss it each and individual part from there on. Just let me stop the share while so that I can share the next thing. So whenever we do with the linked list, generally what we do, generally we follow a simple thing that we don't think that this will be of, say, the linked list node will contain various kind of data and all. So when we will discuss about the single linked list, where we will find the thing that each node is pointed to the next, and that is why in case of single linked list, it can traverse only in one way. Only in one way means that if this is the starting point, then it can go to the next only. It can go to the next only. Now, as of now, as per our basic concept or consideration, we think that this is my starting point, and we assume that from left to right, the single linked list can move in the direction of left to right only. Okay. So see, all these are assumption. I cannot tell that in the memory something is moving in the direction of this or that. The memory, the operations, they track only with the next location address. But the point is they can move in only one way. Now, linked list is also called a linear data structure. Why? The linear data structure concept comes with the fact, yes, one idea that the next element can be accessed directly. Means if I say A, B, and C, B is just, you can say that B is just adjacent to C and A. B is just adjacent to A and C. So A and C both can be accessed directly. They do not maintain any kind of hierarchical relationship. Means B is not maintaining this kind of thing. B is maintaining principle of adjacency. So in case of linear data structure, every linear data structure, if an element can access its previous and the next element directly, means if we consider that this but one element is adjacent to its next element, it's maintaining the principle of adjacency, then only we call it as a linear data structure. And in most of the linear data structure, accessing of the elements is of linear order time complexity. Okay. So this is why single linked list is called linear data structure. Fine. Now, let us go to the point that we have already discussed about the array. What is the special about the linked list? Yes, we can say that array is of in the demand that it has to be stored in the contiguous manner. So there may be a restriction in the space, or it may suffer sometime due to the restriction of the space. But in case of linked list, that kind of issue may not be there. Second, the linked list node are by nature are structures. So you can store various kind of data, but in case of array, they are homogeneous only. But is everything is a problem in the linked list? Linked list can solve these two issues, that's okay. But if we consider the accessing of any linked list data, that is accessing of any linked list node, that is more time consuming than array. If I say that I want to access the fifth element in an array, you can directly write A5. But if you say that you want to access the fifth node data, you need to start from here. You need to traverse here, 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 here. So that's the problem. And is there any wastage of space concept in the linked list also? Yes. How? I am discussing gradually. Now, So these are the things that I have already discussed, that how things may be stored in the memory and all. See, all these already discussed, but how now node structure is maintained? In case of linked list node, there is always a data part and there is one address part. So if I consider a node, say here 5 is there, this part will contain address of the next node. That means when you are creating the linked list, if only one node is being created, this will be null. Okay. If only one node is being created, then this link will be null. This particular information you will get once you create the next node. So this is 104. 104 may be the address of this node. So once you have created this node, then only you will get some value which can be assigned here. If nothing is being assigned, things will be null. Similarly, when the third node is being created, then only this address 602 that can be stored here. And then only it can track. See, we are every time discussing that there is a this line and all, but practically that is not possible. What is possible? Logical. This node may be the first node having the data value 5, and in the address part it is having a address 104. Now, so that means the next node resides in the 104. So it is going, and when it reaches the 104 location, it sees, it can see that there is a data part 6 and the address part is 602. So what does it mean by this 602? Now 602 is the address of the next node. Okay. And in the this node, where you can see that this particular node is having the data part as 10, but address part as null. That means no more new node is attached to it. So this is just a 3-node list, and this is the concept that how things are being maintained. There is no such line exists. What exists? Address of the next node. And if next node doesn't exist, then this address part will be null. This is the general structure of a linked list node, rather single linked list node. Now, so how we can define the node? See, as I have told that this is basically your structure. So use the struct. Node is just the name. It's your choice. You may give your name also. No one bothered. Then int data, as I am assuming the data will be integer. And the most interesting part is this struct node link. And because of this, it is called self-referential. What is this? This is a part of the data. Okay. This part supposed to contain the address. Okay. Address means what? Address means it has to be a one pointer variable. Address means a pointer variable. Okay. Say the name of the pointer variable is link. But what will be the data type of it is? Now, what we have learned earlier, that if an integer pointer supposed to store the address of an integer variable, a float pointer supposed to hold the address of a floating point variable. So if I say that link is a pointer variable which is going to hold the address of what? It is going to hold the address of another node. What is the type of the node? What is node? Node is nothing but a structure. That's why the type is struct. A node link part is going to store another node address. So we know that every time the type of pointer depends on the fact what exactly this is going to store. So what exactly it is going to store, it's basically your node type. What is node? Now that is a structure type. Okay, Shantan, as you have raised the hand, let me allow you to unmute yourself. Yes, say your query. Let me try to solve it. What is your query? You have raised your hand. You can unmute yourself and raise your query. Shantan, are you there?
Ma'am, I haven't raised my hand.
It shows me that you have raised your hand. Okay, fine. Maybe by mistake you have done that. You are
Okay,
showing
sorry,
to.
ma'am.
Fine, okay. Fine. So this is the reason for which we call it as a self-referential structure. Because within the node definition, the pointer that we are using, that is of type struct node, which is the type of the node definition. And why we need to use this, that I have explained. So whenever you use now the node, you need to use this kind of thing, this kind of node definition, where one part will be the data and another part. Now you may ask that can't we take different kinds of data? Yes, you can take. But here now our purpose is to learn that how to deal with the linked list, not with how many data I can store or not. For your own choice, you can take any kind of data and you can proceed with it. Now, what will be the size of the node? See, if I consider that integer is a 4 bytes, so this part is 4. What about this? What about this? Think, and while you will do the program, check that what is the size of a node. Obviously, we will use some node name. So anyway, while you will do the program, first check the size of the node in your system. And I am already telling this is of 4 bytes. You should tell me that what is the size of this. Okay. You need to check whether you know something or not. I am not asking. You need to check and then you need to tell me. Now, when we will deal with the program, linked list program, we start with this fact that there will be a starting node, and initially that will be assigned with this capital NULL null. See, this is null, and in the last class we have discussed about this null. Both are not same. They are not same. Okay. This is a macro used in this kind of pointer assignment. This is a null character used in string mainly. Okay. So next we will go for how to create the list. See, what we need to do, the first job in a linked list program, declare the structure. Once you have declared the structure, then you have declared the start equals to null. Then, so for the creation, what we know that I need to create a node. So how I can create a node? I can maximum take one variable of structure type. Okay. Then I need to allocate the space for that node. So how I can do the allocation? Using malloc or calloc function, which can help us dynamic allocation of the memory. So if we can allocate it dynamically in the memory, we can use calloc or malloc function. Now, once a space is being allocated, then it will return the address of the location or address of the starting chunk. So if I want to allocate a space for a node, that maybe one chunk is there and this is the starting point. So this will be returned to what? Now malloc or calloc, they will actually return the void pointer. So we need to typecast it to the structure type, because the address, it will be stored in a structure pointer variable. Once the memory allocation is done, then what is the next step? The next step is that assign the data part to it and assign the link part. Now, at the beginning, obviously, for the first node, that is the starting node, there is no link. So link part will be assigned as null. And if it is the first node, then it will be also declared as the starting node. So see what we are supposed to do. Consider that your structure definition is there. You need to take the new node pointer and the P as a temporal pointer to be used at various phases. Then use normal printf scanf to collect the data. Now, here the loop is being considered in this way, that till you are giving the -1, it will take one by one value and it will create the node according to those values. So now see what I have told, that you need to create the node using dynamic memory allocation function. So what is, and we are using here the malloc. Why I am using the malloc? Now if I consider calloc and malloc, both are officially used for dynamic memory allocation function, but malloc has more flexibility. Malloc has more flexibility, that it can arrange the space if the space is not available contiguous manner or any. Malloc is flexible than the calloc. So you need to use the malloc, and then you should use the size of struct node. See, I'm using here the type. I didn't have used any specific name or this, so I need to see whenever I need to store the space for integer, I need to write size of int. So similarly, here you are supposed to write size of struct node. Take it. Now, malloc return the void pointer. So new node is type of the struct node. So typecast is to the struct node pointer. And now, so new node is now getting a space. Suppose this is a new node location. Now, in the new node location, use this arrow operator. See, as new node is a structure pointer, you need to use the arrow operator to assign the value in. What is n? N is the data member that you have taken as an input. Next, as this is the starting node, so assign the link part as null. This is the first step of your creation of the linked list. You need to assign this particular, you need to assign the first node link as null. Now, whether it is first node or not, how we can decide it? Now, if starting point is already null, if start that you have done the creation of the node, means the declaration of the node, if start is null, that means the node that you have created just now, that is your starting node. Okay, so if that is, then make the new node as start. Make this new node as start. Okay. Else, what we do? else we need to do this. You need to take P, which is another temporal variable, it's another pointer variable of start node, and then you need to check whether for a node the link part is null or not. If not null, see what it is doing. This is the first node. This is the second node. This is the third node. So it is the start. So P is pointing here for the first time, and it is while P link not equals to null, P equals to P arrow link. So what is the P link? Now this is the value which is nothing but this node address. So P will move here. Again, if the link part is not null, P will move to the next part. That is your the very next node. It will reach to the next node. So it will come down to here, right? Once the link part, suppose this is your last node, it is null, then here suppose the new node is being created. So this link part will be connected to the new node by this line. This is the entire operations. And after the loop for a single time, it will take the input again. If the input data entered as -1, eventually this loop will not work. Okay, so now I have seen that one person had raised the hand. So let me clear the doubt. Yes, what is your doubt? Enrollment number 1077. What is your doubt? What is your doubt?
ম্যাম আমার মানে হ্যাং করছিল ভুল করে হয়ে গেছে
Okay, fine. Okay. So this is the way you can create a list. Okay. Once you have created the list, what will be the next job? The next job should be printing it or accessing it. To display the list. So how we can display the list? You should, what we have known by this time, node, anywhere this way. The link part containing address this, link part containing address this, link part containing address this, and if it is last, the link part will be done. So this is your start. So again take a variable, say P, and assign the address of the starting node. Then, like the previous one of the creation, use a loop and to check whether the link is null or not. But here is a tricky one. Anyway, first let me discuss that what is the thing. So once you have assigned here, it will be moved to here, P arrow link. Again, not null, so it will be here. Again, not null, it will be here. Now see, instead of P link not equals to null, here it's written as P not equals to null. So what is it? See, P not equals to null means, or P link null means whether next node exists or not. If next node doesn't exist, then only I can stop. But to display the data, what is important? Whether this node exists or not. Otherwise, what will happen if instead of this I use this, the content of this node will not get printed. Okay. So you need to take one parameter. Start is declared globally after the declaration of the your that particular, say, the start variable after the structure definition. Then if while p not equals to null, then only you will print the data. See, I have used the arrow operator because everything is pointed, and after that you should proceed to the next node. Fine. So I request you that up to this creation and displaying, do it now. Do it now in your own system. I'm here to clear any of your doubt, but open your compiler, be it online, be it offline. I don't mind. Create the linked list and display it. You should have the option to create multiple nodes the way I have shown you, and you should print the list data. Check whether you are able to do or not, and whenever you face any problem, you can ask me. I'm allowing you to unmute yourself for your queries. So start doing it. Do it. It will take hardly 6 to 7 minutes, but do it. Hardly. If you can, a very few lines are there, do it now. And one more thing, those who are doing maybe for first time, for using calloc, malloc, this kind of header file, you need the malloc.h, that header file too. So use that along with your standard input output header file and do it now. If you have any query, you may ask. Otherwise, do it within next 6 to 7 minutes. I'm here. Just do it or raise your doubt. So is it done? Have you completed? Have you completed? Are you facing any kind of problem? Have you completed? Arey, you are busy with the attendance. I told you repeatedly that attendance is based on your Zoom report. Because Zoom is maintaining the detailed report, how much time you are here, whether you are actually here or not. Zoom maintain that kind of report. Yes. Don't fix the number of node. So I hope you can print the content of the node also. Fine. Which part I need to repeat? Which exact part I need to repeat? You can unmute yourself so you can tell me which exact part you didn't have understood I need to repeat. Which exact part I need to repeat? Anyway, I'm not getting any kind of response. So I am assuming that you are able to do. Oh, P not equals to null and P link not. See, if I consider P link not equals to null, that means P is the temporal pointer where initially you have assigned the star. Then if you move forward, you can check that whether the next node exists or not. So with P arrow link, you check whether the next node exists or not. If P arrow link means if link part of a node is null, it means it indicates that next node doesn't exist. So if next node doesn't exist, then the loop will stop its operation and it will not print the data. But if I want to print the entire list, what should I check? That whether the node exists or not. I should not bother that whether the next node exists or not. I should bother about the fact whether the node exists or not. So if I want to consider whether a node exists or not, I should go in this way. Whether P not equals to null or not the fact whether the P not equals to null. For P arrow link not equals to null, check whether the next node exists or not. So whether a node exists, then you're supposed to print it contents. Yes, you are considering the node, not the next node existence. Whole node, not the next pointer. It's not the meaning. We are checking whether the node exists or not. We are not checking the P arrow link. What? Link part contains the address of the next node. We are not checking that whether next node exists or not. We are checking whether a particular node is present or not. All right. Is it okay? Okay, fine. So next we will move to the next set of operations of the linked list. So next we will do what? We will try to insert a node in the existing linked list. Now, where the insertion can take place? Insertion can take place at various locations. That may be at the beginning, that may be at the end, and that may be anywhere in the list. So what is that? One is at the beginning, one is at the end, and one is at any location, of your list. Okay. So if I want to go for, with this approach, I should mind what? I should mind it in this way, that if I want to add something at the beginning, if I want to add something at the beginning means here, then this node has to be your starting. So the node that you have created, you should make a link to the existing starting node, and after that this node should be declared as start. This is the new node, and this is the, you should declare it as a starting node and declare it as start. That is your insertion at beginning. So you have created the node first, then you are assigning the link part with the address of the previous start node. Once this is done, declare this new node as start. So this is the procedure if you want to insert the node at the beginning. Now, if I want to write it in a code format, so what I should write? First of all, everything in a linked list program is nothing but a menu driven program. So at the main function, you should maintain all the function calling, such as your creation, then insertion at beginning, insertion at end, at any position. So within the function body, what should I write? Again, you should take a new node pointer and a data variable, take the input and then create the node, then assign the data member. As of now, everything is done. Then this new node link equals to start, means address of the starting node. I'm considering that my list is already exist, and as start is declared as globally, which is initially null, but after the creation of the list, start is containing the address of the first node. So you, once you declared new node arrow link equals to start, so new node address part is going to contain the address of the starting node, and once this is done, then only you can declare the new node as start. Okay, so if you have any query, you may ask, because if you understand single linked list properly, you can understand any type of list and you can do any kind of programming with the linked list. So if you have any query regarding the insertion at beginning, you may ask, otherwise I will go forward. If you have any query, please put forward your query. I will try to resolve your query. Any query? Any query? Oh, you all you understand everything. That's very interesting. Yes, everything at this moment I'm discussing for single linked list that I have mentioned at the beginning. Well, so let me go for the next function. Now, if I want to do it, that I should try to enter it at the end. So whenever you go for the next step, that is at the end. So as of now, in the creation of the list that we have done, that it should traverse till the end, and then it should add the new node there, and the last node link part should be assigned with the new node address. We have done this in the normal creation of the list. So this is your new node. You should start, and then the link part is null for new node, obviously. Then you should traverse, and the last node address part supposed to store the address of the new node. So this way you can make the link. And this is the code where you should, like the previous, new node, then creation. This is the declaration, this is the creation, this is the data assignment, this is the null assignment, this is the data entry part, and then you can move forward with the temporal variable p. So you should use this. P is used for traversing the list. So while you are traversing, again you use this statement, and then you reach at the end and you just assign the link part of the p, because this loop will break at the last node, means for which already this was the null. So it will break here, a new node somewhere here and there. So make it non-null by assigning to this. This is the thing this will do. Okay. This is of insertion at end. So insertion at beginning and insertion at end, they are not that much complicated. A little bit complications come when we try to insert a node within an existing list. When we try to insert a node within an existing list, that becomes a problem. P arrow link equals to new node should be after the end of the while. Suparna, I think you didn't understand the loop structure. This is your while statement. I didn't have used here any kind of braces. That means this while can affect only this line. It is, this line is not under the control of this. I didn't have used the braces to indicate what is the block under the while loop. So only P equals to P link is under the control of while. This line will be used once the loop operation will be done. Once the loop will break, execute. I think you didn't have seen, or you just skip it. So you have raised this query. I hope I made your point clear. All the time, if the braces are not required, I do not use the brace if not required, many of the time. People who are continuously writing the attendance in the chat, I'm repeating, that's not required. When you have joined, how much time you are here, whether you are properly attentive here or not, the detailed report is created by Zoom and we get that. Okay. So it's not required to write all these things in the chat.
Recording stopped. Recording in progress.
Sorry for the inconvenience. It just go out of the fact. Well, we are here. So what is our job? Our job is to do it that whenever you go move forward, this is the node which is colored as blue. You are supposed to insert maybe in between A and B. Okay. So in case of linked list program, what we do, now we should start again from the beginning because that is the fact that is known to you. Starter but from you move and you check the value of the existing list with which your query data is matching. If matching, then you should try to insert the node there. So what you will do? Now, suppose initially you have the link from A to B. So now, if I want to insert this node in between AB, if I want to insert it here, then what it should be? Now, it should be marked. The A should connect it to the new node and the new node link should be A should connect it to the new node and the new node link should be connected to the B. But if you directly just connect this link to this, the rest of the list will be lost. So what you need to do? Every time when you are going forward, you need to keep the track of the previous and the next node. Because you don't know when you will get the match of the data. So the moment you will get match of the data, that moment you will connect it to this and you need to store the address of the next one so that the link part of this node can be connected to this. So if I consider the first one, this is your suppose P and this is your suppose Q. So P arrow next is Q or Q equals to P arrow next, you need to store the address. Because the moment you connect P arrow next equals to X, the Q may be lost. So you need to store the address of this next node separately so that you can connect it. Okay. Let me show you that if I put how these things should be done. See, look at carefully. Otherwise, what will happen that when you want to do it by yourself, you may face problem. So insert any is for any position. New node required, P required, Q required, N and M. One is for the data member and one is for the particular node after which you want to insert. So take both the input, allocate the node, assign the data member. Fine, up to this everything is okay. Then you should start with the P. Yes, I told you to do that. Then while P not equals to null means whether the node exists or not. If the node exists, then you are comparing that whether, suppose you have already list 1, 4, 6 and there is a data member 5 which you want to insert after the 4. See, after which you want to insert, suppose you have given the M as 4. Okay, so what it will do? P not equals to null, fine. So this is your starting node maybe. This is your P now. So if this is not null, it will check if P data equals to M. What is P data? And as of now, this is 1. So it's not matching. So if this is not matching, then the under the if statement, this part will not execute. Okay. It will just go to the line P equals to P arrow link. So it will go to the line P equals to P arrow link. Fine. So now it is coming here. So when it is coming here, again it will check if it is not null. So what it will do? Now P data equals to M. Yes, it's equals to M. So that is the 4. So if it is, then Q equals to P link. Now this is P. So what is it is doing? Q equals to P arrow link. P arrow link means what? What this node is containing. What the link part of this node is containing. It is containing the address of this node. So Q is there to store the address of this node. Okay. Once the storing is being done, that means it was 1, then 4, then 6. It was already there. So once this is done, what you can do, this is termed as P, for which the data matching is done, and for 6, the 6 is the next node, so it is assigned as Q. P equals to Q equals to P arrow link. P arrow link is containing this address, so that is being stored into Q. Okay. Now you can make P link equals to new node. P is being linked to the new node, and the new node has to be connected here. So new node will be connected to Q. So this is the thing that you need to do. So I have discussed all 3 insertion functions. Now similarly, if you want that before any node you will do or anything, you just need to manipulate this line so that you can do this. Okay. So please try with, you have already the creation of the list. Try with these 3 functions. I'm giving you another 6 to 7 minutes of time, and then try to display. That is important. Whether you have inserted successfully or not, it's about if you can call the display function, call it and check it whether you are able to do it or not. Okay. So try with this insertion function, all these 3, and with your existing program and display it. If required, obviously you should use the menu driven of the switch case. Do it. I am giving you another 7 to 8 minutes because it takes time to type all these things. And if you face any problem at any phase, please raise your query. I will try to resolve your query. You can unmute yourself, and if you have any query, you may ask, or you just complete it. Just complete it. Just to check whether you are facing any kind of problem or not. Fine. If you are not facing any problem, you do not have any issue, then we will move forward. But before that, please check once. See, you may say that, ma'am, these will be useless. Because many people are thinking, I feel that no one will ask to write the linked list code. The point is, there are fill in the blanks are coming. Where part of the codes are there, you need to fill those up. You need to fill up those blank to make it a perfect code. And this kind of things are coming for linked list. No one is going to ask you. Yes, during the interview, you may be asked to write a single function. Yes, it happened. People are being asked to write a particular function of a linked list. That okay, you know linked list. You tell, yes, I know. Fine, you know single linked list. Okay, write the creation. It happened. It's being asked. It's not like that it's something useless thing. But the point is, more tricky is that the fill in the blanks. Unless until you understood the thing, you cannot do the fill in the blanks. That kind of fill in the blanks come even in the gate and in the placement also. If they think they can give it. You no need to raise the hand, please. You can unmute yourself and you can ask. Whatever your query, you can unmute yourself and you can ask. But please, till now I have discussed the creation, display, insertion at different positions, beginning, end, at after a particular node. So please try all these functions and tell me if you have any query. Then only I will go for the next part. That may be deletion, reversing, and all. So please do it. Yes.
ম্যাম জাস্ট এটা জানা ছিল যে মানে ম্যাম ডেটা স্ট্রাকচার মানে ইন্টারভিউ পয়েন্ট থেকে মানে কতটা মানে লাগতে পারে, মানে শুধু কি থিওরিটিক্যালি পড়লে হবে মানে জাস্ট একটু কোড গুলো দেখে রাখলে হবে না, মানে ডেপথে কিছু পড়তে হবে?
তুমি ডেপ্থ বলতে কি বোঝো? তোমার
মানে
কি মনে
ডেপথ বলতে ম্যাম যে মানে যেমন বিভিন্ন অনেক সলিউশন দেখা, মানে অনেক
অনেক
মানে
সলিউশনস দেখার মতো ভেগ ওয়ার্ডস বলো না, তুমি ডেপ্থ বলতে কি বলছো সেটা বলো।
ম্যাম ডেপথ বলে বলতে চাইছি যে মানে বিভিন্ন যেমন অনেক সলিউশনস করা,
অনেক
বিভিন্ন
সলিউশনস করা বলতে তুমি কি বলছো? এগুলো তো তোমার প্রত্যেকটা জিনিস ইন ডেপথই বলা হচ্ছে।
হ্যাঁ সেটা বুঝতে পেরেছি, মানে মানে আমাদের তো মানে ওই
উপর পড়লে হবে না।
আচ্ছা আমাদের
তোমার
তো মানে কোডিং কন্টেস্টে শুধু মানে ল্যাঙ্গুয়েজ গুলো জানা থাকলে হবে তো, মানে শুধু কি
না,
মানে
ইন্টারভিউ এর সময় শুধু কোডিংটা করতে জানলে হবে না, কোডিংটা এক্সপ্লেন করতেও পারতে হয়।
হ্যাঁ সেটা বুঝতে পেরেছি, মানে ডেটা স্ট্রাকচারটা মানে শুধু কি ইন্টারভিউ পয়েন্টেও লাগবে না মানে কোডিং রাউন্ডেও কোনো লাগবে?
কোডিং রাউন্ডে তো ডাইরেক্ট, সেটা যদি ডেটা স্ট্রাকচার ওরিয়েন্টেড প্রবলেম হয় তাহলে লাগবে। ডেটা স্ট্রাকচার ওরিয়েন্টেড না, যে কোনো প্রবলেম যেটা দেয়া হয় সেটা অ্যালগোরিদমের কোনো না কোনো অ্যাপ্রোচ দিয়েই সলভ হয়, যদি কমপ্লিকেটেড হয় আদার দ্যান দ্য সিরিজ প্রবলেম।
আচ্ছা আচ্ছা
তো
ঠিক
সেটা
আছে।
তো যে কোনো অ্যাপ্রোচ দিয়েই সলভ হবে। আর কোডে কখন কোনটা লাগবে না লাগবে, তোমার যদি কোডটা ট্রি এর হয়, এবার তুমি যদি ভাবো যে ট্রি ইজ আ পার্ট অফ ডেটা স্ট্রাকচার, তাহলে ডেটা স্ট্রাকচারের কোডিং লাগছে। যদি কোথাও তোমার স্ট্যাকের কনসেপ্ট ইউজ করতে হয়, তাহলে সেটা স্ট্যাক, তাহলে তুমি ভাবতে পারো ডেটা স্ট্রাকচার লাগছে।
ঠিক আছে ম্যাম, থ্যাংক ইউ।
একদম ছোট কোম্পানি থেকে, ছোট বা সবচেয়ে ইজি ইন্টারভিউ ফেজ থেকে সবচেয়ে টাফেস্ট কোম্পানির ইন্টারভিউতেও ডেটা স্ট্রাকচারই লাগে। জিজ্ঞেস করে নিতে পারো তোমাদের যে সমস্ত সিনিয়ররা হাইফাই কোম্পানিতে ঢুকেছেন, তাদেরকে জিজ্ঞেস করতে পারো, তাহলে তুমি আরো বেটার আইডিয়া পাবে।
ওকে ওকে ম্যাম,
ঠিক
থ্যাংক
আছে?
ইউ।
মানে তারা লাইভে কোড করতে বলে, একটা পুরো জিনিসের বলে দেয়, বড়সড় জিনিস, সেটা মানে যদি অনলাইন হয় তাহলে স্ক্রিন শেয়ার করে কোড করতে বলে, পাতি নোটপ্যাড। অনলাইন ইন্টারভিউ স্ক্রিন শেয়ারিং করে কোড করতে হতেই পারে। That depends on the interviewer choice. And shorting searching to খুব common. লাক খারাপ থাকলে you can practice the code from anywhere, hacker rank, lead code, whatever you want, doesn't matter. You need to practice on it. Okay, anyway, so anyone is having any query? Have you completed this? Yes, the complexity is also important, and yes, we will discuss the complexity also. How to calculate the complexity, we'll discuss those also. Don't worry. Because whenever you do the code in a competitive coding in those platforms, not only solving the problem is important, it is also important that you can solve them in lesser time complexity, lesser space complexity. So that is important. See, this cannot, it depends on the profile you are applying. If it is a simple bulk recruitment profile, direct simple code may be given to you. But if it is a profile of higher package, even in MNCs or some other product development companies, separate kind of coding may be asked. High level of coding may be asked. If it is a simple bulk recruitment, this is palindrome, string matching, sorting, searching, this kind of coding may be asked. Or sometimes even in the high level company, they start with this, then they go for various other things. Okay. So anybody is facing any kind of problem with this? Anyone is there who is facing any problem with this? Okay, if you are not facing any problem, I can move forward. So now what we will do, that is the deletion. Like the insertion, we are supposed to do the deletion from various phases. Like we will do the deletion from the beginning of the list. We will do the deletion from the end of the list. We will try to delete from any of the location. Okay. So see, if I want to delete from the beginning, think properly. If I want to delete from the beginning, what will happen? I will go and I will delete this. Now, in case of linked list, the deletion is something that need to be called a function, that is freeing of the memory. In that linked list, the deletion means the destroying the links. In the deletion, it's based on that destroying the link is also important. If I destroy the link to the other nodes, it will assume that yes, this node no more exists. Okay. So destroying a link leads to the fact that this node is not more reachable, and you may consider the node is being deleted. Okay. So from different position. If we want, we can go for this deletions. From the beginning, if we want to delete, what we will do? From the beginning, if we want to delete, we will start from here. We will take this node in somewhere else, and we will make, before I delete this link, I should make the next node as my starting node. The next node as my starting node. Okay. So make the next node as a start. Once you can make that, then you can call the free function to delete the previous start node. So what you need to do? The new start will be the start next. This was initially your starting node. So you want to make this node as your start. This is what? What is the address of this node? That is stored in the link part of this one. So start next. This is the start next. Is this node? So start equals to start next. So that means you first need to make this node as a start. Once you make this start, you can delete this. So if you can look at the code, this will be, first of all, if start equals to null, then this is that no node exists or no list exists. Else, you just start with the starting node as P, then you make start equals to start link, and this free function is for deallocation. This free function is not deleting something. Basically, when we are thinking about the deletion of the function, no one of them is deleting. They are doing what? They are just actually reducing. They are just making, or they are just deleting the link. They are just deleting the link. So they delete the link and they move forward. Okay. So they delete the link, and once they have deleted the link, the node becomes a scatter entity, a discrete entity. Just need to do this. They just need to call the free function to deallocate the memory. This is for deletion from the beginning.
Ma'am, what is P here?
P is a node pointer, another temporal pointer variable here.
Okay.
With the help of P, you have assigned the initial start address to the P. Otherwise, if I call free start, then the dangerous thing will happen. You will
yes.
lose the control of the entire list.
Yes. Thank you.
Yeah. So next is, suppose you want to delete something from end. Okay. So that means if I have this list, you want to delete this. Now, how we can understand that this is the end of the list? Now, by checking the link part as null. If the link part is a null in a single linked list, then we can consider that is our last node. So what I need to do now? I need to start from here, from the starting position. I need to traverse. I can check that when the P link is null, I can stop here. Okay. But stopping is not only the thing. What I need to do? I need to make this as null. So how I can understand that I need to make this one as null? So I need to make the program understand that this is the node which is just previous of the last node. So every time, whenever we move forward, I need to keep the track. Means when I am here, suppose this is my next, so I need to make the track. I need to keep the track of my previous node. In the next level, when this will become next, I need to keep the track of my previous node. And this way, when I will come here as a next, This will be my previous node. So once I get that, okay, for the next node, the link part is null. That means now link part of, and you know that this is the last node that has to be deleted. So you just forget about this link. You just make a link this to the null. The moment you will assign the link part to the null, automatically this becomes a free entity. No linkage, no free, so then you can call the free function. So initially we can start by assigning P and Q both pointed to the start. Then at each phase, P will move forward and Q will be lagging behind to keep the track of the previous node. And this way you will go continuously at each phase. And once you reach at the last phase, then this will be assigned as null and you will call the free function for the P. So what you need to do? See, you need to have two pointers that I have shown to keep the track of the present node and the previous node. This P and Q, both structure pointer type of node is being taken. P is assigned with the start. Q is assigned the value of P. Okay. P link not equals to null means next node null. Next node null. That is the checking you are doing. Once, if it is not null, then Q is assigned with the P. So I have shown you already, this is your start, this is your P, this is your Q. At further this, P is assigned the start, Q is assigned with the address of P. So now, if it is not null, Q becomes P and P will now move to the next node. So Q is here only and P is moving to the next node. Okay. This will be continued till the next link is null. This entire operations will be continued till your next link is null. Once that is null, then obviously the loop will break and the Q, what is Q? Now Q is every time keeping the track of P, means the address of the present node. First it is assigned with the Q, then only it's moving to the P is moving to the next node. So Q is holding the address of the previous one, then you assign it to null and then you can call the free function. Okay. This is the way you can perform the deletion of a node from the end. Next, if you want to delete it from anywhere, similarly like insertion from before or after, suppose this item to be deleted, okay. So again, if you need to delete this item, what is important? Now it is important that you should able, means this node should able to get the connection of this. So what is this? This is basically your B arrow next. And this is your A or A arrow next. So this your A arrow next should be assigned with the B arrow next address. Means A link part should get the address of C node. How it can get? Now this is the address that is stored in here. So again, whenever you are moving forward, you need to keep the address in this way. If you can keep, then only you can get the address of the next node. Because you never know which will be the node when you can reach that particular node which to be deleted. So from the user, you need to take the input that which particular value you want to delete. Now you may say that if multiple values are there with the same thing, if multiple values are there with the in a node, in a list, so what we will do? Now definitely we will delete the node with the first occurrence unless until no more restrictions are given to you. So we will remove them from the very beginning of the list. Okay, we will we may need to remove any, so we need to keep the track of the next every time. So if I want to code it, it will be again, you need to take the P and Q as your pointer variable, take n that you want to delete, and again you start from using a copy of starting node with the P, you move forward till it is equals to this n, till it is equals to this n, and you are keeping continuously the copy of P in the Q, then you move forward, and once this point is being reached, then Q link, that is the previous node link in the diagram, the A link will be holding the P link. Because if this is P that you want to delete, this is Q, so Q link, P link means it is the address of the next node, so P link is actually holding the address of this. So the moment I write Q link equals to P link, it is getting the address of the next node. So once that is done, you can call the free function. Okay. So this is the way you can delete it from any position. So again, I request you, I'm stopping the screen sharing for a while, and please try by yourself. Please try by yourself.
Recording in
That
progress.
you are supposed to do. Please try by yourself whether you can do it the deletions or not. Again, you take 6 to 7 minutes, because if you have already started the program, you have everything with you. So please do it. Deletion from any node. Okay, I'm again discussing. See, for deletion from any position, it involves what? Now, suppose this is a list with 3 nodes A, B, C. You want to delete a node, say B. So what you need to do? If I directly make A link equals to null, if I directly make A link equals to null, it will create a problem. What kind of problem? Now, rest of the list is not having any track or any link with the A. So everything will get lost. So obviously that is not desirable. What is desirable? Now, the A must be make a link to the node which is next to the B. So if you want to do it in this way, how we proceed? We generally take the input that what particular node you want to delete. From the user, we want to take the input that what particular node you want to delete. So if you want to take that particular thing, then what we will do? Now, here you know that you need to delete this particular node. But it may happen that you never know that what is the exact position. So every time whenever you move forward, you need to keep track of your previous node, because unless until you have the address of a node address of this node, you cannot make the link part to link it with the address of the next of the node, which is just after the node which you want to delete. So when you want to move forward, you start with the starting node, take the starting address and the P and address of the P, keep a copy with the Q. Now, if the value is not matching, you move forward. So whenever you are moving forward, you are keeping a copy of the node P to the Q. You are keeping a copy of the node P to the Q. After keeping the copy, you just move forward. After keeping the copy, you just move forward. So once you go forward, then you are keeping the copy in the queue. So Q is the node. Suppose in the previous diagram, that is the A. So once the P is moving to the B, Q is pointing to the A. So once the data of the B is getting matched with N, it will break. So if it is break, so what you will do? Now Q arrow link. So A arrow link equals to P arrow link. P is what? P is your present node P. Of QCE, and you call the to free the memory that is occupied by. So is it clear to you? Is it clear to you? So, okay. Okay, so okay, fine. So again, so I request you that those who are doing already, you got the time, but still you check that whether you are able to do it properly or not. Take 5 or 6 minutes of time to check whether you are able to do this or not, the deletion. Fine. I hope you have already the list. Just check whether you are able to do this or whether you are understanding each and everything or not. That's why I'm asking you that type it, then only you can understand it easily. Take 5 minutes of time, then only we can proceed.
Recording stopped.
Everybody mute yourself, please. I am allowing you to unmute yourself so that you can raise your voice for your query. But if you are busy in something else, please mute yourself.
Recording in
Well,
progress.
so if you have any query, you can ask. And as I'm not getting any query, I can assume that you are able to do everything properly. That I'm thinking. I don't know whether you are doing or not, because that is not in That is not in absolutely in my hand. But let me share my experience with the everyday's mock interview that I am facing. I don't know how is your experience, but my experience is at present, most of the students are not at all prepared. Most of them are not even in the level 0. We are not getting the answers of very basic questions even. Don't think that your seniors have grabbed the job. That's why company will come and will offer you the job. You have to grab it. Giving an attendance in the chat box or just present reluctantly without doing any practice, you are not going to get the job. And in the code vita result, I hope you have seen that there are many students who have contacted maybe a senior or one of the faculty member who had tried to solve your query and all, and many of them got the code in the plagiarized form. Plagiarism is a crime, and you can find that many of the codes are get plagiarized, and obviously you will not get results. So that will happen maybe in all the recruitment drive. Unless until you take your own responsibility, no one can help you. If you take even the help, you are not, please remember, you are not the only one who is taking the help. 100 of students are taking the help for a single from a single person. So 100 codes look alike and everything will get rejected. Okay. Anyway, since I can feel that how much reluctant you are, neither we are getting any proper answer in the interview. And during the class also our experience is that, yes, we are as if by doing the screen sharing, we are studying. You are not participating. Most of you. I don't know what you want. Anyway. So next thing that I will discuss, that is sorting of the data in a linked list. Okay. So sorting means arranging the data, be it in the order of small to large or largest number to the smallest number, ascending or descending, but the default sorting order we consider as your ascending order. So say these are the numbers are there. Yes, I will show with the note, but before that, this is the thing. So there are many sorting algorithms. We can take one of them. This 35426 may be your initial status. So you start comparing, you do compare, change the location. You have compared this 3 with this location, and you got from this side this 2, change it again with the 2, do the changes, and if you move forward continuously, you will get the thing. So before coming to the directly numbered thing, we can come with this fact. Sorry, because of my yeah. This is your list, existing list. So what we will do? We will do the comparisons. Okay. In case of sorting, most of the sortings are sorting by comparison. So what we will need to do, you may take any algorithm, be it selection sort, be it bubble sort. Any means anything which is not based on divide and conquer. Because if I want to do divide and conquer over one linked list, that won't be easy to do because I need to count the midpoint, then I need to use them and all. That is obviously not at all a easy to do operation. So I should start from here. Then I should compare it with this location. Once I compare this with this node, I find that, so that means you are comparing P and the Q is your P next. So you are comparing P with the P next and you are getting that, okay, this is the value which is smaller. So exchange the position, fine. Now, from this position, you try for the next one. From this position, you try for the next one. Because you have selected this first position and you are trying to compare it with the rest. So once you compare, you will get no K. 4 is greater than this. So in the next phase, here where we are comparing with the next value, because the previous one is still the 1, 2, 3, third location, the next is 2. So you compare it to 2 and you will find that yes, 2 is smaller than 3. So take the 2. So now here, so next you will compare the next location with 6 and you will find that, okay, you have nothing to change. So after the first iteration, you will get. So what we are doing, again, we need to start from the starting node, assign it to some pointer, and the rest of the node to be pointed with the next. With the starting position, with the first node, we are doing the comparison of all the next nodes. So at each phase, the link will work and it will go to the next node and those data will be compared. Once one iteration is complete, then it will start with the next item. So it will start with the second node and it will do comparison with the rest of the node. Once that cycle is complete, that will start with the third position. See, all these are position based things. It's not about value. The values are getting changed gradually. First, at the beginning of the list, you can find that it is with the 5. But after the first iteration, you can find that it is 2. So it has to go in this way only. So let us go to the code directly so we can understand. So see, sorting is not as much as easy like searching in a linked list, because in case of searching in a linked list is nothing but your linear search, and you have done already the part of the searching operation when you are doing the thing, when you are doing the deletion of any data or insertion, you need to check that where exactly the data is present. So you need to do it in traversing the list by comparing the required value with the existing data. So here you should proceed in this way. P and Q both are there. P arrow link not equals to null. So that I hope I should not mention it again, that why it is. And inside this, you need to check Q equals to P arrow link. So what you will do, suppose P is your first node. P is your, if there is a list, this is your first node. You are getting that this link is not null. So Q is being assigned with P arrow link. So this is now P, this is now Q. So now what you need to check? You need to check that whether the Q node exists or not, whether this is null or exists. So if it is exists, you need to check if P data equals to Q data. Whatever the data part is here, it is being compared with this. So if this is, I'm trying to make it ascending order. So that means it has to be the smallest one, then it has to be the second smallest one. But if it is greater than this, then you need to exchange the swapping of two data values with the third variable. I hope in the third year I no need to explain. swapping of chips. Still I am explaining. You need to take the copy of the data, means this D to the 10. Then this P data will be assigned with the Q data. This is your step 1. Then step 2 is this data will be going to here, and the third step is assignment of this to this. Fine. Once that is done, once this enter operation is done, then Q equals to Q arrow link. Obviously, this node, if it is not null, it may contain some address. If not address, then it is the last node. That's a different issue. But otherwise, it will contain the address of the next node. So next time it will be complete. See, P is, as I am fixing one node, selecting one node as a fix, just like just I do in the selection shot, that I fix one array location. Similarly, I am fixing this position here, and it will compare. It will now compare this P arrow data will be compared with the Q arrow data. Okay, so this way it will continue. This way it will continue. So I request you, please do the sorting. I'm giving you another 5 minutes of time, and I'm requesting you that please do the sorting of the existing linked list. I hope you can do it. So please do the sorting of the existing linked list and do another program. So I am giving you to do 2 programs now. One, sorting, that is I have explained already, and another one is count the occurrence of any number or any fixed number. Let us do it with the any fixed number. How many times a particular number is present in the list? Count the occurrence. Count the occurrence of a specific number, or if you want to do it with the character, you can do it. I'm not stopping from you to do that. Count the occurrence of a specific number in your list and sort the number. Do these two. Take again 6 to 8 minutes to do. Then we can go for the next thing. So please do that.
Recording stopped.
See, today we are doing
Recording
all
in
these basic
progress.
things. The more specific problem regarding the linked list we will do. We will do in the next class. That will involve various kind of logic, various extraordinary things that we will do in the next class. But today we will do all the basics of the linked list, so that in the next class you can easily identify the logic behind each and every tricky program. So please do it. Please do it now and tell me if you are facing any problem.
Recording stopped.
Yes, we will do, but unless until you may be confident about the entire linked list, but unless until uh, I discussed the basics. I cannot go with those problems. I told you already, maybe you didn't have listened, that today we are discussing all the just the basics of the linked list and everything from there. Then we will discuss about the specific problems. There are few problems which are a little bit tricky if I consider as per the linked list. We will solve those problems from there. And you, those who, if and anytime you can solve for yourself from any of the online coding platform. But some of the problems we will discuss in the next class, which are a little bit tricky to solve, not easy to solve or time consuming. Since time complexity is more, you need to reduce. We do all these things in the next class. You no need to remind that what I need to do. I know what I need to do. So you can tell me that what are the problems you are facing. As you have raised the query, you may put forward your query. I will try to resolve your query as much as possible. You may put forward your query in the chat box. I will try to resolve. Put forward your query. Well, so I'm not getting any query from your side. Even the person who has raised the query that I should make you practice from hacker rank, and I told that yes, I will discuss various problems, but if you have any specific query now, please tell your query, because otherwise I cannot understand. You raise your query, then only I may try to resolve it. Okay, you are writing the query. Yes, please write. Others also, if you have any query, you may post here. You may write here and I will try to resolve. Others, please try to do, means if previous are being done, try to reverse the single linked list. Not printing in the reverse order. Others, please try to reverse the list. Please try to reverse the entire linked list. That is again a very common thing are being asked during the interviews, that write the code to reverse the linked list. That's a very common thing that is being asked. So please try that also. Try to reverse the linked list.
Recording in progress.
Yeah, my connection get lost. So if you have written something previously, uh, please write that again here because my connection get lost. Anyway, so are you able to do the reversing of the list? Are you able to do the reversing of the list? Anyway, let me discuss the reversing of the single link list. Okay, you can do the reversing of the single list, is fine. So those who cannot do it by themselves and also cannot raise the concern, let me explain it for them. And then only we can move to second part, means other types of linked list. Okay, I got the query. You are given a string. So first of all, it is not at all a linked list problem. You told me that the linked list problem, you are facing problem and all, but it's not linked list problem. Total number of substring or finding the substring is specific type of algorithm. You can go, this is means this is not that much tough thing or anything. You can go, I hope you have studied. I will discuss those chapters obviously, but before that, if you want to do in the design and analysis of algorithm, there are specific algorithms which deal with the substring operations. You can try with those algorithms. Then it may be means total number of how many total number of substrings such that number by the string is divisible by 6 and all those things. Over though that particular algorithm, you need to apply this, means you need to find what I have understood, that it's a number string. You need to take substring in such a way. So first of all, you need to check how many substring you can generate. And whenever you can generate the substring, you need to know what are the number of combination that can be divisible by 6. So based on that, the substring that you are getting, you need to check for that only. So go for that substring finding algorithm that is there. That is already all the string. Oh, I'm getting confused. The modulo. Oh, acha. It's just a value 10 to the power 9 plus 7. It's a how much large value it is that is given. It is nothing more than that. Means it is the total range that you can take. Total range that you can take. It's not that much complicated. If you read those algorithms which may help you to finding this substring, rest of things are easy. This is just a number 10 to the power 9 plus 7. Nothing else. Modulo means every time dividing the number with that modulo operation. Nothing more than that. It's a normal mathematical operation. Well, so up to sorting we have done. Next we will do the reversing. Again, the reversing involves that you should start, means the special kind of thing is reversing doesn't mean that it will go to the end and it will print the data in the reverse. Reversing means if the arrows are like this is the starting point and this is the end point, it means that after your reversing operation, this will become your end. All the arrows will be reversed. And this last node will become your start node. You need to keep in mind that reversing means this. Reversing doesn't mean that printing the data in reverse manner. So how we can do with this? We can move forward in this way. Again, P, Q, T, three temporal variable of node pointer is being taken. P is assigned with null, T is null, and Q is star. So consider this list. So what we will do, it says that Q is equals to start. Okay. So if Q is start, this is this, fine. While Q not equals to null, okay. Is the Q is null? No, Q is not null. Then T equals to Q link, okay. What is the Q link? Now Q link is holding the address of this node, okay. So it says that assign T with the Q link, so it becomes T. Q link equals to P, okay. What is P? P is assigned with null. It says T equals to Q link, okay. Q link equals to P. So what is my expectation? My start node link path will become the null. See, so Q link is actually null. So you have done the first part. Next, this is your next node. You have already assigned the Q link. So what is next? Next, P equals to Q. Next, P equals to Q and Q equals to T. So what is the Q? Now this is, so make it, and Q equals to T. Now this will become Q and this will be continued. So how? In the next level again, Q not equals to null, then T equals to Q link. So this will be T. And then Q link equals to P. So this link will be reversed and joined here. Then again, this will become this. So continuously, what you are doing, first you have one node. You take the next link in a temporary, another temporary pointer variable, and you are making this null. Then you are again proceeding forward, then taking this link and making this link reverse to this one. And again you are doing reverse to this one. And at the end, when you will reach, make the node, last node, when you will reach here as a P, make that node as start. Fine. So obviously you cannot remember or memorize all these things. What you can do, if you put forth a little bit effort, you can try to understand and try to explain. During the interview, all the time, it may not be possible that you can do one each and every time, one complete code perfectly or anything. But if you at least able to explain how things are going on in the right direction, that also may be beneficial to you. So if you have any query regarding the reversing of the list or any line that you are not understanding, you can explain, you may put forward your query. Otherwise, I will go for, yeah, I'm repeating. There is nothing most important topic. Everything is important. Be it linked list, be it data structure, means be it tree, be it searching, sorting, be it graph, everything is important. It's up to you what. Now if you consider only about those bulk recruitment, then this kind of simple operations means if all the simple direct questions, nothing is less important. C is a subject, DBMS is such a subject, there is nothing less important. We do not go for hardware based papers because we don't consider them as important. Yes, somebody has asked me to repeat the reversing maybe once, so I'm repeating this again. See, yeah, means no one is less important. I cannot tell you that this topic is not important. You have to read all. Now, how much you will read, whether about different imaginary problem and their solution, or you will just read definition and direct program, that's up to you. So what we are doing here, we are trying to do what in case of reversing of the list, it's very important that we try that we will, if there is a list starting with the start and ending with some null, what is our expectation that when we complete the reversing of a list, we will get a list where initial starting point as end point and the end node will be considered as start. So how we can proceed? Now, from the very beginning, we will try to make all the arrow directions. Actually, in physically, there is no arrow, but all the arrow directions to the reverse. And means if I consider my linked list is of like this, 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 then null. Now I want this will be this, 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 this kind of thing I want. So how I can proceed? Now initially this becomes your Q. Okay. If Q is not null, then T equals to Q link. So what you are doing? You are making this as T. Next, Q link becomes P. What is P in a null? So what you are making? This is your Q. This side you have, sorry. This side you have the next node. This is the link. But instead of this, you are trying to forward it to some P, which is nothing but null. So you are achieving this part. You have achieved this part. Okay. So what about this? See, you have arranged Q to this side. What about this? Or rather, what about this? You need to change the direction of this node link to this side. So, what is being done again? The exchange are being done. P equals to Q. What is Q? I didn't have changed the Q address to anything. So, which is initially Q means the node for which you have already made the link part as null. Now it has become P. Okay. What is the Q? Now T. Initially, when you have started, you have taken the next node of Q as T, the second node. So this is now Q. Okay. And again, if it is not null, things are being repeated. So T equals to Q link. So what is the next node? Now this node will become T. Q link equals to P. So Q link equals to P. So that means this connection is being made. Q link equals to P. Again the exchange. So again this will become P. This will become Q. Right? This way it will continue. Once this will become null, so that will stop. Once it is stopped, the last node, it will previously, which was this last node, will be termed as the start. And that's all. Because the end already you have made null in the first step. So this is the last one when you are supposed to get the answer. So is it clear? The person Suparna has asked me to repeat. So is it clear to you? Okay, fine. So now we will do another kind of list. We'll do another kind of list. Let us go for the W link list. Everything is almost same. Just I will discuss the creation, or means just a single function. If you have understood the single linked list properly, obviously you will not face any problem with the W linked list. So what will happen in the double linked list? Now in case of double linked list, we will expect that instead of single link, we will get two different links. Instead of single link, we will get two different links. So one node will be of two different, will be having two different address. One node can have more than one address. One address is for your previous one, and one address is for your next one. So as it has two different points, it can traverse both way. Means it can, in case of single linked list, it can go only from starting location to the ending location. Now it can go for both the direction, means start to end and end to start. It has not to do any kind of complicated reversing or anything like that. It can go two different ways. Okay. So when we are defining the node structure, it should have this way. So whenever we will declare the node, we should do it this way, prev, next and all. Initially you have only one pointer, Now you need to maintain both the pointer. These are again the operations from creation, beginning, end, deletion and all. Now, whenever you need to deal with this, you need to again start with null assignment to the start pointer. Now, when you are assigning the start with this, start means that when the start is null, that means no node exists there. But whenever you create a new node, every time you need to keep in mind that the previous and the next, both the positions has to be declared as null. Whenever now you will create a node like in the single linked list, what you have done, now you have assigned only the link part, only one link part, that is as null. But when you will deal with this node creation, what you are supposed to do, you are supposed to take the previous part and next part both as none. What you will do after that, that's a different issue. Now, whenever you will create the next second node, only this next part will be used, not previous part. Only the next part to be used for the first node. So you will take the new node creation with the same function, the malloc function, and all with the same line. Only the difference is in the size of the node. The size of the node will definitely differ. Assign the data member, new node prev equals to null and new node next equals to null. That is the first step. But whenever you will want to add the new node, what is there means more node, rather more node you want to add for creation of the entire list, then what you need to do, this particular node next part should contain the address of newly created node, and this node prev should contain the address of the first node, means the previous node. Two types of pointer manipulation has to be done for each and individual node. If it is any node, then the pre pointer should point to the previous node and next pointer should point to the next node. It seems very easy when we listen to this and when we try to draw this, but it's not easy when we are trying to implement this. More specifically, whenever we try to insert the node at any position or delete the node from any position, things are not that much easy, because that time you need to deal with many links as compared to much more links as compared to your single link list. Now, start with this. If start equals to null, you make the node as new node as start, else. From here, you need to think more. It's not about that it's start, but you need to think that you have to deal with how many pointers. So you start, you check whether the next link is null or not. The meaning is till now not different. The next node null means, next link null means there is no next node. This node is your last node. So you need to check with the link part whether that is null or not. Then if it is not null, go to the next location, means next node. And once you have reached the next, then new node prev means the point is that like this, if you can if there is one node, let's disturb. If there is a node already and you are creating the new node, that new node is also coming with its two hands, the previous and the next. So the previous thing should connect to the last node. Okay. And for that previous node, the next pointer should be connected to the new node. Previously, when we are dealing with the single linked list, this new node arrow prev, it's not required because there should not be any link of new node to the previous in the opposite direction. So this is the new thing that you have to make when you are dealing with the double linked list. Now, how we can display it? No, displaying doesn't involve any complicated thing. It's again the same thing because when you are displaying the data, we generally go with the first position, the first node, and from the left to right, we just want to display the data for a normal display. But if I want to display it in the reverse, then you need to go till the end, taking the P as your starting point, P makes not equals to null, and you need to reach to the end. Once you reach to the end, then from the Q, you again start and start with Q arrow data and the change the pointer to Q equals to Q arrow pre. So this way you need to change the data. If I want to, means if this way you need to change the link continuously if I want to print the entire contents of the list in the reverse way. So again, I request you that create the doubly linked list and display the content in reverse. Do it now. Do it now. Do it now and just check whether you are able to do this or not. Whether you are facing any kind of problem with this or not. Because once the slides are open and everything is open, it seems that you can do each and everything, but which is not true for all the time. So please do that.
Recording stopped.
So is there anyone who is facing any problem with the doubly linked list concept? Is there anyone who is facing any kind of problem with the doubly linked list concept? Because again, I am telling you that the moment we will go to the different kind of output or error checking or the tricky questions, see, we will use this double link in the tree and graph based thing if required. To code the implementation of tree and graph, we need to take the help of doubly linked list. So if you do not understand that how to make all these link or anything, you can tell, and I can discuss those again. If not, it's okay. It's very good that if you are confident, but if you are not doing anything and then you are telling that you are not, you do not have any problem, that will be the problem. Anyway, so
Recording
I'm
in
not getting
progress.
any query, so I'm continuing with the next set of functions and all. So now for insertion, what I need to do? Again, I need, if I want to insert in the start, that at the beginning, I should first create the node, and the existing list starting node prev pointer should be connected to this new node. What you need to do? Think properly. In case of single linked list, I just need to link the next part of the newly created node to the existing starting node. Here, you need to do that in addition to the fact that for already existing list, the prev part of the starting node should be connected. Prev part of the existing starting node should be connected to the new node. And then only the new node can be declared as your starting node. Fine. This is the list. This is the new node. So this new node next to be connected to the start. Start prev should be connected to the new, and then you declare it as a start. These two lines are very much important. That's new node prev equals to null. That while creation you need to maintain that. But after that, this start prev equals to new node and new node next equals to start. These two lines is actually making the required connections. These two lines are making the actual connections. And once that is done, then only you declare your start as the new node. Similarly, if I want to add to the end, what I need to bother? You need to reach till the end. End means for which the next link is null. That is the end. So now the next link should be connected to the new node, and new node prev should be connected to the previous last node. So how that can be done? This is the creation of the node, assignment of the null to the next. That is the just the part of the creation. P equals to start. With the while loop, you should traverse to the end. Once you reach to the end, new node prev equals to P, new node prev equals to P, and what is P? Now P is previously last node, so P next equals to new node. So you need to do that. Yes, okay. So whatever your query, I am allowing you to unmute yourself. Those who have raised the hand, you may put forward your query. Whatever your query, I will try to solve. Yes, what is your query? Two persons raised their hand. What is your query? Okay, maybe by mistake they have raised their hand. No query at all. Okay, fine. So this is the way you can insert the value at the end. At any position. Now, at any position involve again the same thing. First, you need to reach to that particular point where you want to insert the new node. You need to reach up to that point. Once you can reach that point, then what you will do, suppose you are here and you want to insert something here. So for this node, previous will be the N2 and next will be the N3. Okay, but it's not only this much. For N2, next will be the new node. For N3, prev will be the new node. So as a whole, you need to deal with 4 pointer operations. You have your new node that you have created using malloc function and all. So now for new node, the prev will be N2. Fine. For N3, for new node, next will be N3. Fine. Then this N2, next node is new. For N3, the prev node is new. So altogether, you need to deal with 4 different pointers of 3 different nodes, new, N2 and N3. If you want to insert it after the N2, then N2 becomes the previous and N3 becomes the next, and you need to deal with all these pointer manipulations. So whenever you write the code of doubly linked list and want to insert a node at any position, you need to deal with these facts. So how I can do? I can again take the starting point in a pointer P. I should traverse it and I should check it whether it's matching with my required data D, after which I want to insert. So you need to check it in this way, and like the previous one, Q is pointing to the P next, so P is the present node and Q is pointing to the P is your present node for which you are checking the data, and you are keeping Q equals to P next. So Q is pointing to the next node. Fine. So next you go forward and what you do, so P equals to data. If it is matching, then only you are taking the next address to the Q. And after that, what you do? Now after that, the way I have shown you the arrows in the picture, that you need to take new node prev equals to P. Done. Then what you need to do? New node next equals to Q. Q is what? Q is P arrow next. You have already stored. And after that, what you need to do? Then P next. equals to new node and Q prev equals to new node. So this is the enter. These 4 lines are very crucial when you are doing this insertion of a node at any position in a doubly linked list. Now, if the data is not matching, it will just go forward using P arrow P next. Fine. So this is the way how we can insert any node at any, how we can insert a node at any position of doubly linked list. Similarly, for deletion, we need to start in this way. For beginning, I need to delete this. That means for N2, the prev link should become null. For N2, the prev link should become null. Okay. So N1 will then get free, and we need to make this N2 as start. I need to make the previous link of the N2 as null, and I need to make this N2 as start. So how we can proceed? The start equals to start next means start is initially the N1, start next is the N2. So automatically start is containing the next. Fine. Start next prev. N2 is the start next. The previous of that is start next prev equals to null. So automatically you are cutting down the connections, and then you call the free function. Things will be get, the memory location will get. Similarly, if you go to the end, you need to traverse till the end, and the N3 is connected with the next link with the N4. So you need to make the N3 next as null. Once you make this null, that means this node is no more connected with any node. So you need to traverse again like the previous single linked list program that I have shown, that you need to keep the track all the time, the node that you are passing on. So this way, if you passing on continuously by keeping the copy to the queue, P equals to P next, continuously you are moving, and at the end, when the next link becomes null because you have reached the last node, then you just make Q next equals to null. Q is what? Q is the node that you previously considered as P in the previous iteration. And P prev, P is the node for which the next link is null. That means that is the last node. So P prev equals to null. So this way, with the node which will be considered now as the last node, the Q, both the link, the next and the prev, both becomes the null, and it's now free. From any position, again, you need to deal with different pointers. Suppose you want to delete this N3 node. So what you will do, again, you need to make a link. The N2 next should be connected with N4, and N4 prev should be connected with N2. So the node you want to delete, that is N3, and you need to make these connections. So obviously, you need to make these connections, and automatically then N3 will lose any connectivity, and you may consider that that node is getting deleted. So you start again with P. Once the data is matching, then Q equals to P prev. So the node that you want to delete, say in the previous example, the N3, that is your P. So P prev, the N2, that will be stored in the queue. Okay. Q next, that is N2 next, equals to P next, because you till now P is existing. So that the N3 existing. So N2 next equals to N3 next. What is N3 next? Now N4. So P is pointing to the N3. So this will be P arrow next. And then P arrow next arrow prev. P arrow next means N4. N4 pre Q. What is Q? Na P pre, that is N2. So the connections are being made. Once the connections are being made, things are done. If not matching, then it will go to the next and you just call the free function. Okay. So this is all about the single list and double list all. If you have any query, you may put forward. And otherwise you have the next class. So I am making series here. I'm not finding series here. Do you have any knowledge whether today you have Taposar class or not? Do you have any knowledge? Do you have any knowledge about that? I also do not have any knowledge. Anyway, if you have any query, you may ask. This is all about simple linked list and all. And if we are talking about the circular linked list, then there will be no end point. In case of circular linked list, there will be no end point. The last node will be connected to the first node. Means if it is a single linked list, only the link pointer will be connected to the start again. If it is doubly linked list, then also the next pointer will be connected to the start, and start pre instead of null will be connected to the last node. Fine. So that is the point. In case of circular linked list, there is no question of null. Insertion of beginning or end, things almost same because the meeting point is same. Link inserting or deleting from in between any list, that is also almost same. So this much. If you have any query, you may ask or I can. Yes, I understand, but I don't understand that whether sir will take or not. First,
Recording
now I'm not
stopped.
finding. Maybe sir is joining. Sir is taking maybe class in IM or anything. I don't know that. Because we do not have any information whether sir will take the class or not. Okay, fine. So I have stopped my screen sharing and all. If you have any query, you may ask. And next week, please go through at least the concepts that I have discussed. If you are at least try to do practice all these things, then only the problem that I am going to give you the next week from various sources you can able to solve. Otherwise, things will be useless. Fine. I'm muting myself. Let me call Jiko or anything. Stay here. And if sir join, I will make him host. Otherwise, I will inform you that you can
Recording in progress. Recording stopped.
Sir, have you joined? Tapos sir, have you joined? Because every day you joined with a name IM placement, so but I am not finding. And this is for students. I have called the GCO. GCO will confirm me whether Tapos sir will join the class or not. Uh, if he joins, I will make him. I will hand over the control.